Hello everyone. We're going to be talking about linear regressions, which is the last section in the statistics unit. Um, you're going to be using your calculator for most of this stuff, so I'm going to actually have a calculator on the screen in just a second so that we can see exactly what we have to do. So if you have a set of points, you can use the calculator to find a graph or equation that represents the data. Once you've graphed it, you can use the calculator to find the line of best fit, and as well as the regression to see how close the correlation is. So we're going to go through one example. This table below is the lengths of the right foot and the height of 10 males, and it's all in centimeters. So the very first thing you want to do is you want to go ahead and push stat in your calculator. And then you're going to go to edit, and you're going to put all of the data in L1 into L2. And as you can see, I've already done that here. So once you have all the data in, you're going to push the second button, and you're going to push the Y equals button. And it'll take you to this screen here. What you want to do is then hit enter. And you're going to go ahead and turn on the stat plot. And you'll notice that there's different types of graphs. It tells you that you're using list 1 and list 2, and then there's 3 different types of marks you can choose from. So I'm just going to stick with that first mark because it's kind of the easiest to see. So then you're going to go ahead and hit the graph button. And when you do that, it's going to take you into your graph, but you'll notice that there's just an X and Y axis here. And the problem is that it's not zoomed in the right way so that you can see exactly what you are graphing. So you're going to go ahead and push the zoom key. And if you scroll down, you'll see that you'll get down to 9, which is zoom stat. And you're going to go ahead and enter on that. And it's going to take you into this here, which this is now your graph. You'll notice that you'll have a bunch of different points. They're not connected. It is a perfect scatter plot. So if we want to look at part B now, it says determine the line of best fit for the given data. So once the data is in the calculator and you have this graph all made up, you're going to go ahead and push the stat button. Oops. Go ahead and push stat button. And then you're going to go over to calculate. So if you go down, you'll notice that number 4 says lin reg ax plus b. And we're going to go ahead and we're going to choose that. And again, you want to put and tell that it's L1 and L2 that we're using. And it'll bring up this screen here. And this tells you what A is, what B is. It gives you R squared and it gives you R. We'll talk about all of that in just a second. But you'll notice that A is 4.83 about, and B is 43.82. So to write the equation, all you need to do is write Y equals, we know that our A value is 4.83, and so that'll be X plus, and our B value is about 43.82. So that right there is your equation. Now, part C asks you, what is the correlation coefficient for the right feet versus the height? So that is actually your R value. So this is looking for the R value. And you'll notice in here that it is that R is about 0.9776. So the closer that is to 1, means that it is a better fit. So the closer the number gets to 1, the higher the correlation coefficient, the more correlated the two things are. So you'll notice that for part D, it's asking us, is it a logical premise that foot size and height are dependent? Yes, it is. And then they say why, and they say, well, in this case, R is 0.9776, which is close to 1. So that's almost a straight line. They're pretty well correlated. So part D, what I want you to do, sorry, that's part D. Part E, what I would like you to do is go ahead and try this on your own. It says predict the approximate height of a person whose right foot measures, for part 1, it'll be 24.8. Oops. Part 1 will be 24.8, and part 2 will be 31 centimeters. What you need to do is actually plug those in for your x value in your equation. So I want you to try that on your own. I will talk to you tomorrow. Have a wonderful evening.